We'll start in a few moments, it says. All right, getting us started. All right, we got bell work. Can you hear someone speaking in the background?
Faintly, but yes.
All right, let me close my door. Hang on. Hopefully that's better. My girlfriend is teaching from home this week,
That's a ton better.
and she has one volume and it's loud. My ratio is -4, very good. We just plug in the stuff, n is equal 9, and that's given. So the sum of the first 9 terms is equal to, looks like we are simplifying a bit. Good. And that's how I would do it too. I would just do that little step so you're typing less in your denominator, and it makes typing it a little easier. You know, I don't expect you to type in -4 in parentheses to the 9th power to enter. You'll get a very large number. So I would type it in just like that. And the answer is 52,429. Let me see. I think that's what I got too. It is. That's what I got. Nice job, Annika. Thank you for doing that. All right, let's go on. Okay, this is day 3 of 1.02 Infinite Series and Segmentation. We have quite a bit to do today. I kind of wish I would have separated this into 2 different lessons because I believe it should be 2 lessons. But I'm just following the way they have it set up on your online modules. So goal number 1, we're going to write a series in sigma notation. Goal 2, we're going to calculate the limit of the nth term in a sequence. And goal number 3, we're going to find the sum of an infinite geometric series. And this is goal 3 is what Chloe brought up on day 1 of 1.02. All right, we're going to be recorded like always. All right, of course, make sure you have your paper, pencil, pen, calculator. I know a lot of math teachers, they like guys who use pencil. I actually prefer pen. I think, in my opinion, pen is better for math. And the reason why is because if you make a mistake, you should just cross out the entire line and rewrite it. So that's just my professional opinion. Okay, what we will not cover today, we will not do factorials. So factorials, I will touch on it very briefly, but if when we get to it, if you're still confused on this concept, I will provide you a link to some good YouTube videos that I will screen and let you know. I will not go over limit properties in depth. I'll be very general about it. We will actually do infinite geometric series today, so I don't know why I put that there. Sorry. We're just cross that off. Okay, sigma notation. So this is the Greek letter for S. This is sigma. So this represents a sum. this little notation just represents we are doing a sum. It's a summation of some series. The way that you read this is the sum from n equals 1 to 5 of this expression here, the quantity 6n minus 2. And all you're going to do is you start at 1, you plug in 1 into n, you do the maths, and you get 4. Plus, you plug in the next number, which is going to be 2 into n, you do the maths, and then you get 10 and so forth. Pretty straightforward. So, let's see one. All right. And this one, I typed up everything, so I don't have to write anything, I don't think. So we're gonna rewrite each series as a sum. All right, so this says the sum from k equals 1 to 6 of the expression 4k squared plus 1. So all we do, we start at 1 and we plug it into k. So you get 4 times 1 squared plus 1. And so if you notice, I have this in brackets. And I like using brackets to show each little piece. So I think it's a good idea to do the same thing. So then we go to the next k value, which is k equals 2, and we plug that into the expression. Pretty straightforward. And then we plug in 3, and plug in 4, and then 5, and then 6. Pretty straightforward. Any questions so far in this? And then you just math it. 1 squared is 1. 1 times 4 is 4. Plus 1 is 5. So we just do the math. 2 squared is 4. 4 times 4 is 16. Plus 1 is 17. 3 squared is 9 times 4 is 36. Plus 1 is 37. 4 squared. Oops. 4. Yes. 4 squared is 16. 16 times 4 is 64. Plus 1 is 65. 5 squared is 25. Times 4 is 100. Plus 1 is 101. And then so forth. It is definitely a lot easier than it looks. Yeah. So on your pretest, which everyone should have done already, I think I'm missing a few people on pretest. I have to double check though. So if you haven't done your pretest yet, you need to. It's easy points. All right, and then we just put it all together. And I don't know why I did not finish the problem. Oh, it's because the directions say just rewrite each series as a sum. There we go. So I then rewrote it as a sum. So there we go. And then if it says, you know, what's obviously what is the sum of this series, you would add these up and give me your final answer. You know what, Danica? Everyone failed that pretest except 3 people. 2 people got a D on it, a very low D. It was like a 62.5, and then 1 person got a C. You were supposed to fail that test. If you didn't fail that test, you shouldn't be in this class. You're too smart. I'm a good guesser. All right, this next one. Everyone go ahead and set this up on your paper. We'll give you a brief moment. Okay, I'm just going to show what you should have had from n equals 1 to 4. So you should have 4 terms set up just like that. And then you just do the basic math. Hopefully you didn't type it in because 300 plus 1 is 301, 300 plus 2 is 302, and so forth. So super easy. And then if I ask you for the final answer, you just add those together. All right. All right, let's do this this last one here on this page. Give you a moment. If you're wondering, we have 18 slides to get through. We are on page 8 of 18, if you want to keep track. Okay, you should have enough time to finish. So we just plug in 1 to 4. And that's what you should get for your first step. And then you put it all together, and that's what you get. All right, we good to go on? Yes, I will give you a link at the very. If you hang on, so everyone in here, if you hang on, I will give you a link to download this PowerPoint. I don't want to do it now, of course, because it has all the answers, and what fun is that? All right, so the directions on this one says to evaluate each series. This means I want you to get me a final answer. So k equals 1 to 5. We'll give you, let's do this. When you finish with number 4, raise your hand so I know you're done. And then once I have majority of people, we'll quickly go through it. So while you guys are doing that, I'll tell you a funny story. Well, not really funny story, but my girlfriend bought a mask. It was Among Us mask, and it has a picture of one of the Among Beans, and it says, "Not wearing a mask is sus." It's pretty funny. I like it.
Also, if you get a chance, Dynica wanted to go back to a page like 3 pages ago. It was the very, very first page, I think it was. And I can't raise my
Sure.
hand because of the moderator.
Um, this page, Danica, or before that? Okay. Don't forget, when you are done with number 4, raise your hand. All right, we'll do this. If you are here listening to me, raise your hand.
Hand raised.
If you are here, raise your hand. Just trying to get an idea of who's actually here.
So we don't have an island, but if you check again, you see the same people, we can't kick them out of the room.
I thought Julia was here. She spoke a couple, like a minute ago.
She's listening, but she's not here.
Oh, okay. That makes total sense. All right. So everyone in chat, go ahead and put the answer for number 4. What is the final answer? We got some 45s. We got lots of 45s. Well, with majority and say 45 is probably right. Let's see. 45 is right. Let's see all that fun work. So there is the setup, and then there is each term. So I hope that all of you don't try to type this entire string into your calculator. It's possible, yes. It's just so easy to make a mistake because once you type this much, your calculator like starts to scroll over and you can't see what you entered previously. I would do each one individually and write those numbers down. I think that'll be a safer way to do this, and then type those numbers in to get 45. But you do you, and if you miss stuff on your test or your quiz, I warned you. Trying to help you out. Okay, number 5. I know I didn't give you much time or any time for number 5, but does anybody have an answer for number 5 yet? If you do, go ahead and write it in chat. 105s, got a bunch of 105s. I'm just going to show the answer for that one. People who haven't done it yet, go ahead and work it out later. But I do want to get through some of the harder concepts in this lesson. I think you guys got this down. This is pretty simple. And I will make these downloadable at the end of this lesson. All right, so the last one. Go ahead and write this down. I'm just going to show the work for this one and the answer. So we'll start with the answer. The answer is 42 for this one. I'm just going to show the work. So many examples of easy stuff, right? Let's get to the hard stuff. So that one. Let's keep going. Okay, now we want to write in sigma notation. So I give you a series, and for these, kind of give it away. So this is obviously arithmetic. You can kind of see 5, 10, 15, 20. What are we doing every single time? Yeah, we're just adding 5, right? Adding 5 every single time. So what's the common difference then? Well, you guys already said it, 5. Your first term is 5. And then how many terms are we adding together? Adding 4. Yep. So we can use, because we know it's an arithmetic sequence, we can use the arithmetic formula, and we can plug in this stuff that we identified. Plug in your first term, plug in the number of terms, and then plug in the common difference. that's to find the nth term, right? So hold off on finding n. Sorry, don't plug in n yet. We have to derive the actual formula before applying it to the sigma. So we plug in your first term, we plug in your common difference. Do not plug in n yet, because all that's going to do is give you the nth term. You plug in 4 right here, you get 20 for the answer. All right, so from this step, after plugging in your first term and your common difference, we simplify this. If I get my pointer out, we simplify this. We distribute the 5 times n is 5n. 5 times -1 is -5. So we do that. So we get 5 plus 5n minus 5. Combine like terms. 5 minus 5 is 0. So all we're left with is just 5n. So that means that a sub n equals 5n. So from this step, this tells us the expression of that we'll use in our sigma notation. So again, this right here gives us our specific term, our particular term. So if n is 1, 5 times 1 gives us 5. If n is 3, 5 times 3 is 15. If n is 2, 5 times 2 is 10. So that's a good way to check to make sure our derived expression is correct. You just do quick checks. Yes, the top is 4. So then once we have that, we just plug everything in. Top is, so we're going from n equals 1 to 4 because that's how many terms we have in our sequence. And then we use the derived expression, which is 5 times n. Okay. Next one is more or less the same. It is. N will always, yes. Yeah, so I would say that's probably always true for the problems that we're going to be doing. N should always equals 1 because we're starting at the first term. Now, if I tell you what's the sigma notation for the sum of the 10th through the 15th, then n would be 10 to 15. So I don't think that you're going to have problems like that, but you could in other classes maybe later on, but not in this one. Right. So I kind of give away. Yeah, I should have covered this up. So because I have an R here, what does this tell you? Yeah, it's geometric. I gave it away because that's the common ratio. So on your quiz, on your test, you won't have those little fill in the blanks of what's R or what's D to kind of give it away. It's geometric arithmetic. You have to look at the series, the sequence, and 2, 6, 18, 54, 162, and you say, well, 2 plus 4 is 6, but 6 plus 4 is not 18, so it can't be arithmetic. And then you say, okay, well, 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. Hey, it's geometric. You have to do those tests. But we also subtract a 5. We do. So going back to this first one, we use this formula. You plug in 5 into your A1. You plug in 5 into D because that's your common difference. And then let me get a different color pen. Let me use a white one. Let's see. We are distributing 5 times n and 5 times -1. So 5 times n is 5n, 5 times -1 is -5. And then like terms, 5 and -5, they cancel each other out. Those are like terms. You're welcome. All right, so we know for the second example, number 8, the common difference is, the common ratio, pardon me, is 3. Your first term is 2. The number of terms we have is 5. And we are going to use the geometric formula, which is right there. A sub 1 times the common ratio raised to the n minus 1 power. We plug in a sub 1 and we plug in r. So we got 2 times 3 raised to the n minus 1 power. Can we simplify that further? Can I do 2 times 3? We can't. Why not? What about the exponents? Remember, terms are separated by plus or minus signs. These would be considered products. So why can't we combine the 2 and the 3 somehow? What about the exponents? So it's not really so much the exponents we care about here. So I'd recommend all of you to look up exponent rules. If you, again, you want me to find you a good video, I will. In order to combine to have a product, the bases must be the same. Now, if I have, let's say I have 2 to the 5th power times 2 to the 6th power, same bases, we add exponents. And because the bases do not match, I can't do anything. So review your exponent rules. But that is that's the reason why we can't do anything else to this to make it more simpler. Because we are done. It is simplified form already. All right, n equals 1 to 5. And then of the expression, don't forget parentheses. It's important. 2 times 3 to the n minus 1, and we're done. And we can always check our answer or some terms. So from this step, we can plug in like n equals 3. And we can plug it in to make sure we get 18. We can plug in n equals 5, and make sure we get 162. So it's just maybe check the middle and then the end. And I think that's probably sufficient to make sure that this is done correctly. All right, so that was an example of arithmetic and geometric. Let's see. Now for these, so you're going to have problems that they won't be arithmetic or geometric. So 1, 4, 9, 16. Looking at this, 1 plus 3 is 4. 4 plus 3 is not 9. 4 divided by 1 is 4. 9 divided by 4 is not 4. So it's not arithmetic or geometric. These would be the harder problems because then you have to think. You got to think about what formula can I derive that will give me this sequence. So looking at from 1, 4, 9, 16, do you recognize anything mathematically going on here? They multiply by 4. 1 times 4 is 4. 4 times 4 is not 16. So nope. 1 plus, nope. It's like George got it. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Nice job, George. So George figured out the math going on. Again, these problems are hard because there's no like formula to plug it into. You have to look at it and you have to recognize these patterns and what math creates those individual terms. And this is why it's hard for some people are really good at identifying patterns and what's going on mathematically. Others are like, oh, I need a formula to plug into. And people who rely on formulas, this is going to be very hard. So logic is a hard thing to teach. You know, I think you teach logic by strengthening your math skills. So 1 squared is 1, 2 squared is 4. So what is the formula in terms of n? I have to have n in there. N squared. Yep, it is n squared. Yep. So you're always squaring it, right? So you're always squaring that term. So 1 squared is 1. When n is 2, 2 squared is 4. When n is 3, 3 squared is 9, and so forth. So we created the formula, n squared. Now so I'm going to go back a page, and this is more like a thinking. I probably could have avoided all of this work. And I probably could have gone right to the formula if you just think about, hey, 5, 10, 15, 20, what's going on? I'm multiplying your place n equals 1, n equals 2, n equals 3, n equals 4 by 5. 5 times 1, 5 times 2, 5 times 3, 5 times 4. If you would have recognized that, we could have skipped all of this math and gone straight from the question here right to 5 times n. Ooh, isn't that neat? I think it's neat. Looking for this one here, 2, 6, 18, 54. See, this one's actually not, I couldn't do this in my head. For the geometric ones, you probably have to do it this way, unless your brain is bigger than mine. All right, so going back here, so we now have the derived formula, or expression, sorry, n squared. So we're going to do n equals 1, 2. How many n values we got? How many terms we have? 4. So n equals 1 to 4. Yep. And then n squared. All right, 4, 8, 12, 16, 20. Well, 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. Hey, actually, we're adding 4 every single time. How neat is that? So I could do number 10 like we did on number 10, 9, 8, number 7. Or I could do it how chat's saying. 4 times n is, get my pointer, I always forget. Is 4 times 1, 4? Is 4 times 2, 8? Is 4 times 3, 12? Yes. So a lot of you in chat have figured out the expression for n. So we're going from n equals 1 to what? How many terms? 5, yep. And for n. I think these are, for me, these are kind of fun. It's like a little puzzle. You got to figure out the pattern. I like that. You know, I know fun is relative and subjective. My fun is probably not your fun. Let's keep going. Slide 13 of 18. This is a long lesson. I gotta hurry up. Okay, this is fun. I'm gonna give you guys a moment to look at this and see if we can figure out what's going on. 2/13 plus 6/13 plus 24/13 plus 120/13. Hmm. Ooh. This is a tricky one. I need Mike. What are you talking about?
Can I use Mike to explain it? Because I can't put it in words.
Sure.
Okay, so what they're doing is you're using the top numbers, the numerators, and the first one multiplied by 3, right, to get to 6. Then they multiply the next number by 1 more. So this was 6 times 4, and 24 times 5.
Ooh, I like that. So, yes, you are correct. 2 times 3 is 6. 6 times 3 is 24. 24 times 4 is 120, and so forth, right? Yeah. You think, well, how do I put that in terms of n? I have to somehow incorporate that, right? So this is not, we haven't done a whole lot of this, but factorials. If you see a pattern on your quiz, on your test, on your homework, remember your homework is those learn and practice modules which are required. Hopefully everyone is doing them. And by the way, I can see your progress in those, so make sure that you are going through those modules. They're pretty decent actually. A little wordy, but pretty decent. So factorials. 1 factorial is just 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 1. Sorry, 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. So if on your assignments, your test, you see a pattern that goes 2, 6, 24, 120, that is a giveaway. It is a factorial. So I would write that somewhere in your notes that pattern, 2, 6, 24, 120, that's the factorial sequence. Not very often we see it. And when you do see it, if you're not fresh on factorials, you won't know what's going on. You won't recognize it right away. I don't understand factorial. So again, I would check out YouTube after this, Sarah, and talk to me afterwards. Did the video I sent you yesterday help? All right, I'll send you another one about factorials, okay? As a little refresher. But this is what it is. I wrote it on the screen here. I didn't expand it of why it's 120. I will do one of them on the board real quick. So 5 factorial is 5 times 4. Oh my gosh, my 4 times 3 times 2 times 1. That's 5 factorial. 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and so forth, right? So in a way, I can actually rewrite 5 factorial. I can, if I wanted to, because your learn module might kind of explain it this way in a weird sort of way. I don't know. I can rewrite 5 factorial as 5 times 4 factorial. In a way, I'm factoring out a 5 out of there, right? Because that's what 5 factorial is, right? Or I could do 5 times 4 times 3 factorial. So I can kind of split it up any way I want. It just looks different, but has the same mathematical value. So that's a little crash course in kind of factoring factorials in a weird kind of way. How did I get? I clicked on the color. You click on the color, then click on it again. It'll pull a little menu thing down. I know. The more you know, right, Antonio? Right. So that means looking at this, the numerator, is this n factorial? Does n, when n is 1, is 1 factorial give me 2? No, it doesn't. In order to get 2 in my first term, n must be equal to 2, right? So what should the numerator expression be then? If I want it to be 2 factorial for my first term, what should I write here? And try not to say too much without giving away. Yeah, so Jacob got it right. N plus 1 factorial. Yeah, you were correct. Nice job. So that's be n plus 1 factorial. Because n, so when n is 1, 1 plus 1 is 2, and 2 factorial we know is 2. That's correct. When n is 2, plug in 2 here, 2 plus 1 is 3, and 3 factorial we know is 6, so that works, and so forth. So remember, let me go ahead and write this down. N equals 1, 2, 3, and 4. So yeah, don't forget that little piece. You know, that's your first term, your second term, your third term, your fourth term. And then what does the bottom always equal? The bottom is always 13. So that's the easy piece. Always 13. And we can always plug in your n values into this equation we derived, right? To make sure that we get all 4 of those terms. And we do. So now we have everything we need. N equals 1 to 4 because we have 4 terms, and then we use our derived expression there. So if you're good at patterns, this is probably pretty easy. If you have a hard time with patterns, this is going to be very difficult. All right, let's keep going, guys. All right, enough with that. Yeah, make sure you do your modules, your learn and practice, and do the examples there. And they're really good examples. All right, if you got to go, you got to go. We still got 8 minutes left. Araceli, I see you. Limits. That's the last part. We only have 4 slides left. All right, limits. So we kind of did this last term when we talk about limits, how as x approaches infinity, how x approaches negative infinity. This is kind of the same thing. But instead of using variable x, we're using n, right? So this is telling us the limit of as n gets really big of this expression here. We want to know what happens. Well, when n gets really big, what is this expression? What does it do? It gets bigger. It gets bigger forever, right? It goes to infinity. So if it goes to infinity, does this expression have a limit? The answer is no. So the answer for this one on this screen is the limits equals none. Because the limit goes to infinity, there it means it's limitless. So there, the limit is none. So that's the little piece that's different from last term when we did limits for like domain and range. You know, as x went to positive infinity or negative infinity, we want to know what happened to y. Y goes to positive infinity or negative infinity. So in this case, this limit is talking about, is there a limit? And because this goes to infinity, there is no limit. That's why it's none. Hopefully that's clear. It always gets harder. All right. So this page, you can either write this down, or at the very end, I'll give you a link to download the PowerPoints. Whatever you want. Whatever you want. It's kind of a lot to write, but this is also kind of like last term. Looking at this, so we have a limit as n goes really big of a fraction. If it's top heavy, if the power is larger in the numerator than in the denominator, this tells us that the limit is none, because this right here, if you graph this, this would go to infinity, right? So that means there's no limit, just like on the previous page. If the exponent is larger in the denominator, that means that the limit of this, it approaches 0. So in other words, it gets really small. You think about it. If like 1 divided by, let's say n is 1. 1 squared is 1. 1 over 1 is 1. Let's say n is 10. 1 over 10 squared is 100. 1 over 100 is much smaller than 1. Let's say n is 20. 20 squared is 400. 1 divided by 400 is even smaller than 1 over 100. So as n gets bigger and bigger, you can see, because it's a fraction, right? That bottom portion gets bigger and bigger, which means the value overall gets smaller infinitely. So as n gets really big forever, your expression gets really small and it approaches 0. So if you don't understand what I just said, it's okay. Just remember this rule. If it's smaller than the denominator, my English not so good. This should probably say smaller in the denominator. Yeah. It's just this should probably say bigger in the. Yeah, I don't know what I wrote here. So these words don't make a whole lot of sense. Just know if it's bigger on top, there is no limit. If it's bigger on bottom, it approaches 0. And then if they are the same, you take the ratio of the coefficients. So in this case, it would be 2 over 3. And this is just like last term. We did the coefficients. 2 divided by 2. I'm sorry. Why did I write 2 divided by 4? Wow, this slide has so many mistakes. I think I was tired I think I was tired by the time I got to this slide. I'm sorry, guys. This should be a 3 here. That should be 2 over 3. Oh, man. Yeah, cross that out, put a 3. Sorry. I remember to fix that. We're done with this. All right. And I have to rephrase these bullet points because they don't sound good. By the way, your Learn module does a much different approach than what I just did. I did a very simplified approach for the limits, very simplified. So I think, Chloe, you go through this before lecture. Caitlin, I think you might also. It's different. Their way, they skip a lot of steps in their math that I noticed in their modules. Kind of hard to follow on this part, at least when I went through. It was hard for me to follow what they were doing. But the most important piece, I think, even if you don't understand their method when they try to explain it, which is okay, if you understand this, apply how I'm showing it to those problems to see if you get to the same answer. You should. If you don't, message me on Skype so I can take a look at it and maybe help you out. Okay? Yeah, Caitlin, I agree. I agree. So this part of the Learn module is kind of hit and miss in terms of understanding. And then there's also they did a mistake on one of the examples. It was one of the first few. I forget which one. But anyway, Anyway, all right. So this one, limits. As n gets really big, of -3n squared over n squared minus 4. What is that limit? Go ahead and write it in chat. We got -3 as one answer. Another -3. I got another -3. Yeah. So the reason why it's -3 is because the exponents here are the same. So we just take the coefficients. So that is going to be -3 divided by 1, which equals -3. -3. All right, number 13. What is that limit? It is definitely 0. I thought it was negative because the fraction. Sarah, you talking about number 12? It is. I wrote -3. Do you not see the minus sign in front? Okay, so you good? All right, Naya. See you tomorrow. Remember, the quiz is today, by the way, for this section 1.02. Oh, yeah, there's an assembly. Oh, yeah. Okay, so let's go ahead and finish this up. This is the last slide, I think. Oh, no, there's 2 more. Oh, my goodness. Let's hurry up. So this is definitely, it's bigger on bottom, so the limit is 0. Number 14, looks like they are the same exponent-wise, so that's 2 over 7. And number 15, it's bigger on top. So if it's bigger on top, it goes to infinity, which tells us there is no limit, right? Saying no limit is implying it goes to infinity, whether it's positive or negative. But don't put NA. NA is not applicable. It is applicable. There's NA and none don't mean the same thing in terms of math. In other scenarios, it can. It's 17. Okay, this is the last piece. It's very quick. Yep, I'll do very quick. So we have sums of infinite geometric series. So if you think about it, if a series goes on forever, you would think if something goes on forever, how can I add it up? How can I add an infinite number of numbers together to get a finite solution? It sounds kind of hurts my brain. How can I add an infinite number of numbers together but get a finite solution? Whew, mind blown right now, right? Well, you can only do this in a very particular scenario, and that's when the common ratio is less than 1. Now, if you think about that, right here, when the common ratio, the absolute value of it, is less than 1, that means that every term you are multiplying it by a fraction. So let's say I started at 1 and the common ratio is 1/2. 1 times a half is a half. A half times a half is a fourth. A fourth times a half is an eighth. An eighth times a half is a 16th. So that number, as the sequence goes on, it gets smaller and smaller. So in those cases, we can actually add up all infinite, also all those terms, and get a finite solution. I know it's crazy. And that formula is right here. The sum of an infinite geometric series, when your common ratio, the absolute value, is less than 1, is A1 all over 1 minus R. Very simple. All right, so 64, 32, 16. The common ratio looks like a half, right? 32 divided by 64 is a half. 16 divided by 32 is a half. So your R value is 1/2. So we plug that in. Your first term is 64. So I would type this in and hit enter, and you should get 128. Next example. -4 divided by 12 is -1/3. 4/3 divided by -4 is also -1/3. So the common ratio is, well, -1/3. Your first term is 12. Yeah, you type all that in and you math it, and we get 9. And the last one, -8. -8, it's -48 over 5, -288 over 25. The common ratio, -48 over 5 divided by -8. Math is hard right now for me, but that is that is 6/5. And then your first term is -8. You type it in, and we get 40. Here's a question for you guys. In this problem, -8, -48/5, -288 over 25. If you notice, every number is negative. If every number is negative, how did I get a positive number for an answer? How is that possible? Let's big brain this, guys. Why? Why is it positive? Do you see this being a problem? Does this raise any flags in your head saying, hey, this doesn't seem right? Yeah, mine too, a little. So, why though? Did we make a mistake? Oh, Chloe got it. 6/5 is greater than 1. Yeah. If you notice how quickly I went past that common ratio, I didn't want to make it, I didn't want to ask you if it's less than 1. It's not. 6 over 5 is, was it 1.2, I think? That's definitely greater than 1. So, can we do the summation of this infinite geometric series? Yeah, the answer is no. Yeah, the answer is no. So, yeah. So, the answer is no. We shouldn't have even done this. This is not less than 1. Sad face with a tear. So yeah, that's no good, right? We can't do that one. On your quiz, on your test, they don't try to trick you. I just want to trick you on the last problem, just for funsies. All right, go back to the last slide. Other than that, we are done. Let me make the slide downloadable. Let me stop the recording. And as always, guys, I hope you learned something today, and I will see you all tomorrow.